Poor installation is the most common source of error in soil moisture data, but there are techniques that'll ensure perfect installation every time. Here's a list of items you'll find useful when installing Terros water content sensors. Soil moisture sensors should be installed into the part of the soil wall that's undisturbed by compaction or digging. Installing in disturbed soil won't give you a representative measurement, as the soil properties have been altered. In order to measure correctly, all parts of the sensor needles need to be in direct contact with undisturbed soil. If any part of the needle isn't touching the soil, that part of the sensor may be measuring air, disturbed soil, or pure water, which will confound your soil moisture data. It's important to remember that each sensor has a volume of influence, which is the volume of soil that the electromagnetic field can reach. Sensors need to be spaced far enough apart so that one sensor won't interfere with another's volume of influence. Details about your particular sensor's volume of influence can be found in the user manual or on the meter website. When repacking the soil, it's important to carefully repack to a soil density similar to the surrounding native soil. Compacting the soil too tightly destroys soil pores, causing the water to move more slowly and along different pathways. On the other hand, repacking the soil too loosely could cause preferential flow of water along the sides of a borehole or trench wall, enabling water to move deeper into the soil more quickly. When selecting a site, there are certain things you want to avoid. Be on the lookout for large rocks. Pushing a large rock into the soil could either bend the needles and destroy the sensor, or create air gaps, causing errors in the data. For the same reason, avoid accidentally inserting your sensor into large roots. However, you shouldn't select a site because it's an easy place to install sensors. Site selection should be based on the statistical relevance of its characteristics to the research question you're trying to answer. At Meter, we recommend a borehole installation. This method causes the least amount of soil and vegetation disturbance, which helps avoid changing the soil hydraulic properties and ultimately the water balance at the site you're measuring. Step 1 of a borehole installation is to determine the desired sensor depths. These will be based on factors relevant to your research question. Typical considerations may include rooting depths, soil horizonation, World Meteorological Organization standards, and more. Before starting, lay a tarp near the area you'll be digging. This will allow you to collect and return the native soil to the borehole. Use a 4-inch auger to bore to the deepest desired depth, plus an additional 10 to 15 centimeters to allow for the lower portion of the installation tool. It's helpful to empty your auger after only 4 to 5 turns, so the soil will remain loose enough for the auger to easily discharge. Empty the soil in ordered piles as you go. This allows you to return the soil in the correct order and avoid mixing the horizon layers. After the borehole has reached the correct depth, measure to verify. Use the borehole tool to install the deepest sensor first. Before inserting your sensor into the installation tool, label each sensor with the intended depth. Place a label at the top near the stereo plug that inserts into the logger. This will help you keep track of sensor depths and make it easier to dig up a sensor later if needed. In a field notebook, record each sensor's serial number, the corresponding depth, and data logger port, plus any other information about the site that may be hard to recall when analyzing the data, such as cover type or notes about an irrigation system. Set the base at the desired depth. Clip the sensor into the borehole tool by inserting it into the trough. The trough will need to be in the non-extended position. Run the cable along the handle and clip it into the cable notch, allowing a small amount of slack. Insert the borehole tool straight down into the hole to the desired depth, using the plate as your guide. Avoid tipping the tool as you insert. And don't drag the sensor needles along the side of the borehole. It's easy to knock the sensor out of the trough. Rotate the lever to insert the sensor into the sidewall. After the sensor is released from the tool, pull the tool out of the borehole. Repeat the process for other sensors in the profile. Make sure to leave enough room between each sensor for the bottom portion of the installation tool. It's best to stagger the sensors slightly around the borehole so the cables are slightly offset from one another. For shallower installation depths, reach an arm into the borehole and press the sensor into the sidewall, but be sure to insert it as perpendicular to the borehole face as possible. Finally, check that sensors are working correctly with a handheld reader such as the ProCheck or a data logger. This will ensure the sensors are fully functioning and giving reasonable values before you fill in the hole. If you want good soil moisture data for the entire duration of a study, it's imperative that you protect your sensors and cables from factors that would destroy them when you're not on site, such as rodents, shovels, and tractors. Run above-ground cable through a non-conductive conduit to protect from rodents. Push the conduit down the borehole at least 15 centimeters or 6 inches, making sure not to interfere with sensors in the vicinity. This conduit end will be buried with the sensors to ensure rodents can't enter. Use bentonite around the cable or conduit if desired before backfilling with soil. Bentonite helps prevent preferential flow down the cable because it swells up and forms a seal. Run the other end of the conduit up the data logger post for approximately 60 centimeters or 2 feet. Zip tie the conduit to the post. If you're burying your cables to protect from rodents, run them laterally underground. Backfill with native soil and repack to the correct density with the tamping tool. Plug the sensors into your data logger. Zip tie cables to the post, leaving a small amount of slack so they won't be pulled out of the logger. Close the lid of the data logger over the labels for protection from the weather. Replace the soil in the reverse order of removal to maintain the correct horizon layers. Add in layers, tamping as you go. Do not overpack. Some people prefer to repack the soil after each sensor is inserted rather than waiting until the end. If you do this, make sure to leave enough space between sensors so the borehole tool can be inserted properly. At the top of the borehole, mound the soil slightly to allow for soil settling. Spending a small amount of extra time to get your installation right increases accuracy and pays big dividends in saved time, effort, and money.